Hello everyone, good evening. Hello everyone, good evening to all. Is my voice is clear? I am audible to you guys. Is my voice is clear? Please respond in chat box yes. And can you see my screen? Please respond in chat box. If my voice is clear and you can see my screen, in chat, please respond in chat box. Just like put yes only. Oh, okay, super. Let's get into session. Today is the second day of our 21 days masterclass on VLSI design. Today we are going to see about FPGA only. Today we are going to see function of the FPGA and the logical blocks of FPGA and functionalities and workings of FPGA and what are the design flow in FPGA in this session only, today only. Let's move to what is FPGA. FPGA stands for Field Programmable Gate Array. FPGA is a lead modern design. They are digital design. They are replacement for the typical ICs. They are a unique architecture made of interconnects and changeable logical blocks and allows to designer to make a custom digital circuit using the hardware description language like VHDL and Verilog. FPGA is a replacement of the ICs. Because of ICs, some low cost ICs, low performance ICs, they are not doing huge performance compared to FPGA. So that we move to FPGA. The reason of the FPGA shine because of fast paced world to digital tech. We can able to reprogram and reconfigure the FPGA. The power of the process is also high. So that we are using FPGA very huge nowadays. FPGA are enforcing how digital innovation will develop in future by spending up algorithm and high-level programming languages and high-level performance computing. FPGA is computing high-level computing algorithms like analog to digital converting and some more digital complex circuits also. FPGA can do anything. If you want to make FPGA as a microprocessor, you can do, and you can make a FPGA as a microcontroller also. We can do anything in the digital circuits in FPGA. FPGA are reprogrammable design application functionalities required for after manufacturing. We can also design and reconfigure the FPGA after the manufacturing of the FPGA chip. And then we move to why FPGA. Because FPGA is a very speed and very user friendly to the reconfig, and we can change the functionalities of at any time, and we can add peripherals like Ethernet, USB Mini 2.0 and audio codec, and we can add another peripherals. We can also use a serial transmitter. We can control the LED lights like we can control the thousands or 10,000 likes of LEDs we can control it. Because of FPGA also acts as a microcontroller, so that we can control all the LED all complex combination of the LED circuits also. And we can improve the speed for specific computation by using the FPGA. And then we can see history of the FPGA. The first stage of the FPGA is based on PLA, programmable logic array. It is fully based on AND gate and OR gate. The PLA is a fixed architecture device with programmable AND gate and OR gate. The PLA is fully based on AND plane and OR plane only. Basically, type of programmable logic is used to build reconfig digital circuit. And PLA also acts as a memory. We can use a PLA at also memory itself. Memory can. And coming to programmable array logic. It's also like a PLA, but and plane is fixed, but we can R plane is fixed, but we can program a unplane. We can change the unplane of the IC. And going to SPLD, to refer any type of simple PLD. SPLD is simply based on combination of the PLA and PAL also. And coming to the CPLD, CPL is a complex PLD CPL is a complex program, complex PLD. It is combination of the CPLD and SPLD functionalities. And coming to the FPGA, it features general structure of allows to have very high logic capacity. Like we can add PLA, we can add PAL functionalities, and we can add CPLAD in the FPGA. This is a basic structure of the CPLD. CPLD is an interconnection of the PAL devices and PLA devices. We can see here there is a lots of in the picture only 4 PALs only it's having, but real time it having a lot of PAL logic blocks. We can interconnect by using the wires of interconnection wires, and each PAL having IO blocks. Every PAL blocks having the IO blocks, it for the passing the inputs and outputs to the PAL. We can achieve the decides required functionalities by using the PAL, but the speed of the execution of in the PAL is very low, so that FPGA and SPLD, CPLD is we are using for that only for speed purpose in FPGA. The main difference of the CPLD and FPGA is a speed performance. And FPGA has a combination of the logic cells. The cells are made up of logical blocks. FPGA allows you to design completely custom digital logic design by in the logical blocks only. It is a faster, FPGA is faster than microcontroller, and FPGA doing the parallel processing. The main difference of the microcontroller versus FPGA is microcontroller can't base it on parallel processing, but FPGA doing a parallel processing. The implementation of the FPGA is very simple because of by using hardware language we can implement any digital circuits onto a FPGA. We can also implement DSP, and DSP means digital signal processing, and Fourier transform and timing and a discrete timing analysis. These are complex logics or we can implement in FPGA, but in microprocessor we can't implement. It is more difficult to implement. But FPGA gives a easy way to implement, like a DSP and a discrete time analysis and so on. This is a basic structure of the digital to analog converters. This is a one logic. FPGA having so many logic blocks. In particular blocks, this is a particular blocks for functionalities like analog to digital converter. The outside of the logic blocks having IO blocks. IO blocks means analog. In the block diagram, analog inputs are given to input, and in this block there is some cells. The cells are doing some actions to convert analog to digital signals. And the RAM was used to store and to transfer to the outputs. Because of every system based on memory. Without memory we can't do anything, because of we have to store the data and we have to pass the in output blocks. So that FPGA also having flash memory, internal configuration memory. I will tell you in upcoming slides. In this slide, this is output of the logic block. This is input block. It is a input for analog signals, and converting here these cells are nothing but transistors, CMOS transistor. Last class yesterday I told you, in the blocks having number of transistors, the transistor fully based on CMOS. So in the CMOS the CMOS transistor, converting the analog to digital. These are based on HDL code, Verilog code, and we can get output from output block DA. There are many output IO blocks in FPGA. I will tell you in upcoming slides. This is if you can convert this masterclass into 1 month intensive, because of in the free 21 days masterclass you can get knowledge, but by using this master intensive you can get certification and you can more accessibilities like code and all. I will say you what are the benefits you will get. These are the benefits you will get. They are all the 30 days recording sessions you will get, and also all the 30 days PPTs and the exclusive project codes, and you can download also, and VIP community group for your doubt clearing and internship updates, and you will get also into ITE intensive confirmation letter, and you can get also 90 days of LMS course access and assignment and tasks. Because we giving a lots of assignment and tasks to improve our knowledge in every day by day, and weekly and week basis also. And you can join weekly live sessions for your doubt clearing and all. And we will teach you resume building and mock testers, and you will get internship and participation certificates in the internship of 1 month. If you guys are really interested, you will get at 799, but your regular fee is 1,999. For the in the internship in the masterclass session, you will get discounted fee is rupees 799. You can register by using the link in chat box. Our organization will post the link in chat box. You can use that link. You can join our internship of 1 month. This is only for limited period offer. Please guys, make it available to you. It will helpful to get knowledge in master in VLSI design. And this is the architecture of the FPGA. This FPGA consists of lots of blocks like IO blocks, logical blocks, programmable interconnections, RAM blocks, DSP blocks. There is a lot of more blocks in single FPGA. The logic blocks consist of RAMs, DSPs and PCI Express also. The fabric all the parts FPGA heterogeneous computation platforms. Because of all these computer resources can be accessed at the same time. You can access all the logic blocks at the same time, and you can access the specific logic blocks. If you want to access these 3 blocks at the time, each blocks having the lots of fuses like a cells. In the cells having the transistors. Yesterday I told you, nowadays ICs having lots of transistors like billions, trillions. Like that, each blocks having the separate logical elements. Logical elements is nothing but transistors only. The FPGA blocks FPGA architecture is based on logical elements. Some FPGAs having the 50k logical elements. Some FPGA having the 100k logical elements. They are varying by the logical elements. If the FPGA having logical elements is high, you can access the logical elements in various way. Like you can access the Ethernet, you can access the USB, and you can access the displays like a CCAC display, and you can access a mic. You can converting analog to digital circuits, because it is fully based on logic elements. And the speed of, and also if you want to high speed, you have to choose FPGA having a huge number of logical elements. An FPGA basic structure consists of logical units. The placement of the placement of the logical elements is unique, and each manufacturer have to design the placement block diagram. It is fully based on top level engineers like front end engineer, highly experienced person only to placing and creating the architecture of the FPGA at the previous first stage of the FPGA design. This is a logical configurable logical blocks. This is the these are the I/O pins of the FPGA, and inside the boxes having this is the CLB, configuration logic block. Inside the CLB having the logical elements, we can interconnect the CLBs by using the interconnect wires or interconnect cables. It's mostly based on wires only, because of we giving the input in for particular CLB in this by using these wires, we can get output anywhere of the FPGA. There is lot of pins over the FPGA. We can give input from these pins, we can get output from this pin also. This all transferred by using the interconnect wires. These are the wires. There is a matrix of interconnect wires. We can use the FPGA uses to transfer the one CLB to another CLB data. The CLB consists of the LUT. LUT stands for lookup table, and flip-flop and muxes. Configuration logical blocks. The CLB is functions of based on combination and sequential circuits. You people may know that combination and sequential circuits, like combination means adders and encoder, decoder, multiplexer. These are the combination circuits. Sequential circuits like flip-flops and latchs. The combination of the sequential and combination circuits is called as CLB, configurable logic blocks. First we see the lookup table. Lookup table, which forms the FPGA architecture, is among two crucial components. Crucial components like conventional circuits like multiplexer, adder, encoder. This all comes inside the LUT, lookup table. And it takes thousands of SRAMs bits and 1,002 multiplexers. There is we can use in the lookup table we can design the lots of multiplexer, thousands of decoders, thousands of adders, thousands of encoder, decoder, multiplexer, demultiplexer also in the lookup table. It is fully based on top level engineering, allocating in the it is fully based on how much of the CLB having logical elements. If the CLB having the low logical elements, we can't design the too much of the combination circuit like adder and full adders. And coming to the flip-flop is mainly used for storage purpose. Flip-flop runs under the clock only. If the clock pulses if the flip-flop having clock pulses only, it can transfer the data from LUT to muxes. The flip-flops having the separate clock management. We have in the FPGA boards having two clock oscillators. Like one is the physical clock oscillator. It will give the 20 up to 25 to 100 megahertz, and there is an voltage control oscillator. By using the voltage control oscillator, we can also generate high frequency clocks by using the VCO, voltage control oscillator. The clock sources which must be jitter free. There is some restriction for the flip-flop. They are jitter free, low power, and highly precise duty cycles. It all getted by using the VCO or PLL. There is a concept of PLL. I will teach you in upcoming classes. PLL is nothing but phase locked loop. It means we can compare the original clock oscillator in the FPGA and the voltage control oscillator in the circuit. By using these two, we can control the clock frequencies. We can attain the required frequency by using the PLL. These are the functionalities of the configurable logical blocks. And this is the architecture of the DSP blocks. I said to you already. We can access the we can design the DSP in the FPGA. We can design the any combination circuit in any complex circuit in FPGA, so that we can we can fix this logical CLBs as to do for doing for DSP blocks only. This we can in the architecture, this row is fully fixed for DSP blocks. This row is functional to DSP processes. DSP means nothing but digital signal processing, but it is useful for converting digital to analog, and we can also converting the low level frequency to high level frequency, and also it is useful for DSP blocks are used in FPGA for the communication technologies like satellite communication, telecommunication. We watching TV daily. The antenna having the DSP blocks in FPGA. And our setup is having the one PCB board. In the PCB board there is a FPGA or microcontroller, but on that IC inside the chip, it having the DSP blocks, and that particular box doing the DSP performance. And then we go into the RAM block. We can assign the RAM block on FPGA also, and we can but the FPGA having the separate internal configuration memory. Internal configuration memory is nothing but we have to load the code in the FPGA in the memory only, so that the FPGA having separate internal configuration memory, but we can also change the FPGA to RAM also by using the way of assigning some large CLBs for purpose of for the RAMs. It is fully based on HDL hardware description language like Verilog. By using the Verilog code, we can change the logical elements in FPGA. This is a main advantage of the FPGA. We can use the logical elements whatever we want, so that we can change the logical elements to RAM. And this is the whole concept of the basic architecture of the FPGA. I said we can use the CLBs as a memory, Ethernet, and PCI. PCI is nothing but it is a protocol to you can communicate the another computer via the PCI only. We can communicate one device to another device by using the PCI, but there is a lot of protocols like I2C, UART. This is only the protocols like I2C and UART was only suitable for small circuits and small device only. By using the system to system communication, this is fully based on PCI only, peripheral connecting devices. And in the FPGA we can also transfer the high speed data in gigabytes also, GB also, in gigabits also. By using the Ethernet, we can access the up to 10 GB speed by up to 10 GB. But in microcontroller we can't access this much of high speed data transmission. But in FPGA we can attain that high speed transmission. It is fully based on how we design the code, how we using the logical elements, how we assigning the logical elements for each peripheral component like memory, Ethernet, PCI, and ARM. In the architecture I am using the ARM. This is for processor core. There is two types of processor core. They are hard processor and soft processor. Hard processor is a process physically implemented on silicon. If in FPGA, if FPGA is based on hard processor, it is physically implemented. We can't change it to soft processor. And that the function of the hard processor is, it is a basic function. It does all the activities of the FPGA. It's like brain of the FPGA, like that only. But soft processor is it's like a low speed. Hard processor performs high speed at high frequency. And also hard processor requires high frequency clock pulses to function the high speed data. But the soft processor requires the low speed only. so that we only get to low speed data transmission, and we can't do all the combination of the we can't do complex circuits and digital implementation in the FPGA. And then we are going to there is a design flow of the FPGA, for FPGA. FPGA is a programmable logic device. I already know that there is a tools for to program the FPGA, like Xilinx, Vivado, and the lattice semiconductors, microchip also giving the microtechnology tools. It is freely available for the market. In upcoming class, I will teach you how to use the tools. And FPGA is useful for dedicated perform task for dedicated task only, because of every time we can't change the program, we can't reprogram the FPGA, but all the times. So mostly FPGA useful for dedicated task and functionalities like ASIC also. And all the programming languages is fully based on operating system, like Python, Java is fully based on compilation and interpreter. It fully depends on operating system like Windows and Macs. There is a difference between Mac and Windows of Python and operating system. But compared to FPGA or hardware description languages, our FPGA hardware description language is not depends on OS. We can write the code in Linux OS like Ubuntu. We can also write in Windows. We can write in Mac also. Why? Because it is fully based on tools, industry tools. If you want to configure if you want to reprogram the FPGA or any other ICs, it is fully based on tool only. Like softwares like Python and Java, it is open source and we can easily write the code. It is only for software. But we have in the VLSI we have to give the correct design for the hardware. It is depends on, there is lots of risk in the write the code, because of we have to ensure timing, we have to ensure clock frequency, we have to ensure the IO blocks, we have to ensure all the logical elements, how much the logical elements we need that, so that it fully based on hardware description tools like Xilinx, Vivado, and Intel Cortex Prime also. The FPGA having design flow, the first stage of a design flow is design entry. Design entry is a first stage of the design flow of FPGA design flow. The process of the design entry is the top level engineer write the hardware description languages. Generally, HDD is better option for the design involving the more complex system, because of it is faster and a language based process, and eliminates the need and eliminates the design in low level hardwares. However, it is fully based on schematics and the RTL code only. And in the design entry, there is a main procedure is a FSM, finite state machines. The state machines based on strategy of another options. It is fully based on the every complex logical circuits is based. It is designed by state machines. In future classes, I will teach you what is FSM, how to write FSM code. This is the first stage of the FPGA design flow. And the next stage is the RTL design and simulation. A digital circuit's RTL design is an intermediate representation that concentrates on the data flow between the registers and operation carried of the data. It is based on the what are the designs and what are the requirements of the FPGA. And before that, the synthesis and implementing phases, we have to ensure the functionality of the performance of a design are confirmed via RTL simulation. In every I already said no, some industry tools like Xilinx and Vivado, they have the simulation part also. If you first we have to write the RTL design for our circuit, and we have to write a simulation for that. The simulation is fully based on Verilog and the system Verilog code. And but in current scenario, most of industry people using the UVM language. There is UVM languages used for simulation testing the RTL design, or the UVM stands for Universal Verification Methodology. The RTL simulation tools like Model Sim, XSim and VCS are commonly used. The functional timing simulation made possible by these tools aid in early detection and correction of the design flow of the performance of bottlenecks. And the next process of design flow is synthesis. In the stage of synthesis, converting the RTL code to synthesizable and a logical gate. This is a process of a synthesis stage, which has been entered into actual circuit components like gates, flip-flops and multiplexers among others. This process of input is transformed into a netlist that have a logical components and interconnects required for particular hierarchy for your projects. There is every CLP having the logic blocks. We are using RTL code to gate level netlist. In the stage of a synthesis, there is a process like interconnection. Interconnection is based on making connection between the logical elements, logical gates in the FPGA. We can easily, but we can't connect the logical elements by the humans. It is fully based on tools like Vivado, Intel Cortex Prime. It is made faster to implement by reducing among the logic, by getting the shrinking and design overall sizes. This is a process undercomes by synthesis and implementation. Implementation is a process of the physical implementation of the ICs or FPGAs. There are three stages in the implementation. First one is map and place and route. We can see one by one. It is all determined by determine the layout of your design. FPGA vendors supply the tools used to step because of they are experts on converting the synthesized netlist into FPGA. Already said no. The synthesis at the synthesis stage, we changing the RTL code to gate level netlist. In the implementation stage, we converting the synthesized netlist to an FPGA. The tool initial step is to compile all the user specified constraints along with the netlist files. These limitations may be related to pin assignment, locations, and also timing specification like maximum delay or clock input period. And the implementation is then mapped out by the tool constraining the resources that are actually available on the FPGA are being used with the resource requirements that is specific in the files. The whole process like mapping and placing, routing is fully undertaken by the tools only. Just we have to assign the IO pins and we have to assign the clock frequency. FPGA having lots of clock frequencies, so we have to assign the pins in the tool itself. And last stage of the FPGA design flow is testing and debugging FPGAs. We have to ensure that our FPGA, we made one FPGA IC, FPGA kit. We have to ensure that it performs our required specification. We have to ensure that it is satisfies the performance standard like testing and the performance of what are the outputs it gives. Like if you design the FPGA like if you want to 25 megahertz clock frequency output, we have to ensure that we have to test that. Why? Because of maybe hardwares, mostly hardwares make a mistake. There is tools also make a mistake. Our RTL codes, there is a mistake in RTL code also. So that for that reasons, the output frequency outputs also getting wrong maybe. So that we have to testing the FPGA and debugging if the error is happen, if we get not required outputs, so we have to debug the FPGA designs like RTL and logic synthesis. We have to change the whole the design, and we have to change the required design in the process of the testing and debugging FPGA designs. It is by using the simulation like Verilog simulation and in-circuit testing. The simulation process and in-circuit testing is fully taken by tools only. We have to see the output and we have to ensure that it is correct or not. Because of tool, VLSI tools won't check the required outputs. We have to ensure that it's showing the results in transcript. We have to ensure that it is correct or not. And then move to internal structure of the FPGA. Internal structure having the logic block already seen in architecture, logic blocks, routings, I/O blocks, and so on, and like memories, core processors, and so on. The logic blocks are consist of transistor and the NAND gates, and sometimes it is fully based on circuits only. What are the circuits we give into the we given in the RTL or we given in the design? It will made in the logical blocks, CLBs, in the FPGA, like transistor pairs, combinational gates like NAND gates and XOR gates, and mostly designs are full. Most of the CLBs only having the NAND and NOR gates. Because of NAND and NOR gates is universal gates, we can design design all the combination circuits, all the sequence circuits by using the NAND and NOR gates. The logical blocks only consist of NAND and NOR gates, multiplexer, flip-flops, and memory registers also, and also multiplexer, and sometimes there is a need for the AND OR gate. The FPGA tool like Xilinx, we have to assign the AND OR gates in the logical block. And this you can convert this masterclass into 1 month internship. What are the already said no? What are the benefits in the internship? Like you will get 30 days recording session, all 30 days PPTs, codes, VIP community for doubt clearing, and you will get IET certificate confirmation letter, and you can access the 90 days LMS course. In the LMS portal, there is a 30 days of the recorded videos, PPTs, and assignments, tasks. We can give a response in LMS portal. It will help to improve knowledge, and we giving the live sessions for every week, and we giving a resume building ideas to you, and we also giving a mock testers for your interviews. Some people studying in final year, so it may be helpful for you. Please avail it. And finally, you have an internship certificate. We will give you internship certificate and the participation certificate also. It is for that 1 month internship. The regular fee is 1,999. In the masterclass session, so that we discounted fee is 799 only. We can, if you guys are really interested, you can avail this 1 month internship by using the registration link in the chat box. Our organization will give post the link in chat box. We can use that. For it is simple, and it is a simple form only. We can easily fill the form. It is a limited feed offer. Please guys avail it. It will end by 2/8/2004. It means next month 2. We are going to practice in the master class is by using this FPGA only. This is a Max 10 FPGA board. This board having the, I said already, we can interconnect the lots of peripheral devices by using the FPGAs. This is Ethernet port, and this is a USB, and this is for the video camera display, camera interfacing. This is for audio interfacing. This is a power supply. We can also there is a I/O pins also. We can connect other GSM or other controller. We can use the I/O pins for serial monitor. We can see the output from this I/O pins, and there is a separate LEDs, like these are the LEDs. It is visible for you. These are the LEDs. We can see the LED blinkings by the required for the specific design. This FPGA is fully we can reconfigure. We can dump the code by using the JTAG. This is JTAG interface by using the USB blaster. This FPGA is Intel Altera FPGA. Max 10 is the name as Max 10. Every FPGA Max 10 FPGA is fully based on Intel quartus tool, and other like Spartan boards. Spartan board is based on Xilinx tool. There are a lot of vendors in market. They are giving the FPGA boards. Each vendor having the separate tool. Like Intel having separate tool like Intel Cortex Prime. Xilinx is owned by AMD. AMD is giving the Spartan boards. So that AMD giving the separate tool for their FPGAs like Xilinx and Vivado. By using the tools only we can program, but this is a Max 10 FPGA board. We can't use a Xilinx for that to dump the code in the FPGA. Only we have to use the Intel Cortex Prime tool for reconfigure the tool FPGA. In this 21-day master class, we will be learning this FPGA only. I will teach you how to access the peripherals like Ethernet, USB, and how to dump the code in the Max 10 FPGA, and how to access the GPIOs. GPIO is nothing but general purpose IO pins. This all we will learn in this master class. And finally, coming to advantage of the FPGA, we can by using FPGA we can do anything in digital circuits, because of we can change the FPGA as a microprocessor, microcontroller, and we can imagine the thousands of LEDs. Like we can glow the LEDs as per what I want, what you want. So that FPGA, by using FPGA we can do anything in digital circuits, and it is super fast also, because of FPGA consists of 5 frequency clock oscillator. By using the clock oscillator we can get a super fast data transformation, and it is a field programmable. The massively and the FPGA is based on parallel processing, but the microcontroller is based on serial process. Like that, we can example analog to digital converter. There is a 50 channel for input to FPGA, like analog signals. We can get from one pin out in digital signals. Like there is a 50 channel to give inputs in FPGA and 1 pin per outputs. That is a process of the massively parallel, and the FPGA having a lot of I/O pins. In the Max 10 FPGA having the 484 I/O pins. So that in that particularly Max 10 FPGA having the 50k logical elements in the single IC. In the single IC having the 50k logical elements, so that we can do many things by using the FPGA. And coming to disadvantage of the FPGA is expensive, but compared to ASIC it is low cost, but FPGA is expensive. Why? Because of there is a lot of interconnection, lot of logical blocks in the IC, so that it is very hard to make one FPGA, so that the price of the FPGA is high only, and it is also use high power consumptions. By compared to ASIC board or other DSP boards, other PLA boards, it consumes only 3.3 volts only. But the FPGA needs a 5 volts, 5 voltage input, and FPGA is volatile and boot time. Volatile means if you dump the code into FPGA, it will useful for only system is on only, FPGA is on time only. If the FPGA is off time, the whole data will be gone, because of it is volatile nature. And also FPGA need a boot time. Boot time means nothing but FPGA if you on the FPGA, if you give the input to FPGA input supply, it will take some time to boot up the process, so that it is also one disadvantage of the FPGA. And there is a high pin count. High pin count means there is a lot of pins in pin inputs and pin outputs in FPGA. Many people may confuse that which pin have to give, which pin is for clock, which pin is for Ethernet. There is a lot of ports in the FPGA like Ethernet, USB. So maybe confusion may be happen in the pin assignments. So that it is also complicated, but it's fully based on pin concepts also. And there is many traps, like we have to study the data sheet of the FPGA first, so that based on if you won't read the data sheet, you can't reconfigure or dump the code into FPGA, because of we have to ensure that which pin for clock frequency, which pin for the IO input IO GPIO pins, so that we have to ensure that this is all the comes under the traps. So that, but if you read the data sheet, you can easily dump the code without traps, without complication, without the disturbance. And tools also simple, tools also very complex, because of each vendors having separate tools. So there is a complex in tools like Intel Quartus. Every tools differ from each other, so that it is also complex. And how to choose the tools, and the RTL is not simple, because of complex or digital circuits. You must have the experience that to write the RTL code. These are the application of the FPGA, like in the aerospace field, medical field, digital signal processing, video imaging and processing, data center, and automotive. Conclusion: the FPGA dynamically devices to allow flexible order implementation. The main advantage of the FPGA is it's flexible. We can change we can assign the complex logical circuits onto the FPGA without need to custom silicon. We don't need to change the silicon. Silicon means FPGA don't need to add another hardware with the FPGA to change the process. It is fully based on FPGA only. We can easily change the circuitry functionalities of the FPGA. That is the main advantage of the FPGA. And FPGA will be flexible for digital circuits and so on. Thank you guys. Thank you for listening. We will see in tomorrow. Tomorrow I will show you how to install the Intel Cortex Film tool, and how to install the Xilinx and the Vivado tools, like that. Thank you guys. Thank you for listening.